Here's a sample page that includes two update panels, each of which contains a single label control. So here's Update Panel 1. It has a label. And here's Update Panel 2, which has a second label. The way that this first update panel is updated is using this Update button. So when the user clicks this button, notice that it's an ASP.NET Server control, it's going to execute the server-side code, update button _ click. So let's take a look at that. Here's the code. And as you can see, it updates both of the labels with a string that represents the current time. So some very simple code. But notice that Update Panel 2 doesn't have anything that causes an update. And here's the async postback trigger that links that update button with updating Update Panel 1. And it's linked to the button's click event procedure. Here's the interface when I run the page. So I'll go ahead and click the button. And I'll click it again. And notice that both of the labels are being updated. But how can that be? Only Update Panel 1 has a trigger that's linked to that button. Well, the reason for this effect is that by default, all update panels on a page are updated with every AJAX response that the page receives. So even though there's no explicit AJAX request that's occurring for Update Panel 2, its contents are being updated along with the other Update Panel control. So here's where the Update Panel control's Update Mode attribute comes into play. By default, its value is set to always, so that its content is updated on every AJAX call. So as you can imagine, this might have some nasty side effects, particularly in more complex pages. But even in this simple page, we have an unintended consequence. So let's go back to the source. What I need to do is change that update mode property to conditional. So I have a commented out update panel control definition for both of these, but I'm just going to copy that attribute and put it within each of the update panels. And I'll save the file. I'll go ahead and run it again. And I'll click on the button. And now you can see that only the label control in Update Panel 1 is being updated because it's the only update panel with a trigger that matches the event that the button fired. Now as I change the page, Label 2 is never going to be updated because there's nothing in the page that causes Update Panel 2 to update. Now, a significant limitation of the Update Panel control is that a page can only have a single pending AJAX request from update panels that's outstanding at any given time. If you have multiple update panels on a page and the user causes a new AJAX request while another request is pending, the results of the first request will be lost. This isn't a severe limitation for most simple pages, but keep it in mind as you design your AJAX pages. You may have to use client-side AJAX instead of partial page updates in order to update some of the page to avoid losing responses. The ways you can combine update panel controls is virtually unlimited. Depending on how the partial page postback areas on the page are related, you can also nest update panels, controlling their relationship through the Update Mode attribute. This is a handy technique when you want a region on the web page to refresh whenever its parent refreshes. But the child can refresh independently of the parent. You can nest update panels as deeply as you wish, and all descendants refresh any time an ancestor refreshes. One limitation of nesting update panels is that when a parent update panel refreshes, all its children and descendants always refresh as well. If the refresh behavior works for the page, it actually simplifies things quite a bit. You can change the default behavior by changing the update mode setting for one or more update panels and programmatically calling one or more of the control's update method. So let's see how you can do this. Here's the multiple nested web forms page that I'll use to demonstrate the behavior of nested update panels. I'll go ahead and start by running the application so you can see what it does. So we have 4 update panels all together. Each of them has a button that refreshes the time. So if I click the button at the topmost level, it's going to update all of the times for all of the child controls. Hit it a few more times. And now I'll go down to level 2 and refresh there. Notice that the data is refreshed at this level and below, but it doesn't refresh the parent. I can go down another level, and level 3 only updates itself and its nested update panel, but not its ancestors. And then I can refresh level 4, and it is the only data that updates. If I then go back up the hierarchy and click, say, in level 2, then once again, only the current update panel and its descendants are updated. And if I once again click the topmost level, then you can see that the time is updated for all of the update panels. So let me scroll down and we'll first take a look at the innermost update panel, which is update panel 4. This is easiest to see the structure of the update panel and its content. So notice that the update mode is set to conditional, and it has a content template that consists of a panel with the grouping text that says level 4. And then it contains a button. This is an ASP.NET button that is a server-side control, and it has the text refresh. And then it has some static text, and then a code nugget that runs every time the update panel executes. And this is a little bit different than other samples, because the button doesn't cause any server-side code to execute in terms of an event method within the code behind file. But by its nature, an ASP.NET button causes a postback, and it's going to be a partial page postback because it's contained within an update panel. And that's going to refresh the contents of the update panel. And each time the contents are refreshed, this code is going to execute again, and it's going to display the current time. All of the ancestor update panels are structured pretty much the same way. So here's update panel 3. It again has a content template with a panel, a button, some text, and a code nugget that updates the time. The only difference here is that it has a nested child update panel. And as you continue to go up the hierarchy, once again, have an update panel 2, has all the same contents with a nested update panel. So that's how the page is structured. The whole point here is that because the update panels are nested, the parent's refresh overrides the conditional setting of the child, but the child doesn't cause the parent or ancestor update panels to refresh. The whole idea of an update panel is to minimize the amount of data retrieved from the server. Only the HTML necessary to update a portion of the page. Thus the name partial page postbacks. This raises an issue. How and where on a page should you locate one or more update panels? The answer will determine how successful you are at minimizing the size of the response from the server for a partial page postback. In order to determine the optimal use of update panels on a page, you first need to identify the portions of the page that make sense to update in response to a user action. The goal here is to absolutely minimize the HTML returned. So if the contents of just one div tag need refreshing, wrap only that div tag in an update panel and leave outside the update panel all the other div tags and other content on the page. If only the contents of a drop-down list need refreshing, include only that drop-down list. If a single cell in a table would change, don't include the entire table in the Update panel. In general, wrap the absolute smallest area of the page that you can get away with. Include nothing extraneous. Now, one limitation of the Update panel is that you can't wrap it around incomplete chunks of HTML. The hardest example of this is a table row. You can't wrap a table row, but you can wrap the contents of a cell or the entire table. It may take some experimentation to get the results you want while minimizing the amount of data returned from the server. You also need to examine how different parts of a page will refresh relative to each other. Should all areas on the page that can refresh in response to a user action always refresh? Or should just one or two? The Update panel's Update Mode property gives you granular control over refreshing multiple areas on the page. Another issue is that you need to clearly define the conditions under which a portion of the page will refresh. Is it a user action? Well, that should probably be by far and away the most common condition. If so, what kind of action? On which controls? In other words, determine the one or more events that will cause each update to refresh. Finally, you can implement one or more update panels for each updatable region on the page, associating update triggers with the events that can cause a refresh of that region, and coordinating the refresh behavior of multiple update panels if necessary. Now, it might be tempting to just wrap an entire page in a humongous update panel. This might have some small benefit in eliminating page flashing compared to a full-page postback. And the amount of data retrieved from the server would be similar either way. But with just a little work, you can do so much better, making the page respond far more quickly to user actions and reduce the network traffic used by your application. Using partial page postbacks on an ASP.NET page is as much art as science. There are no hard and fast rules to follow. Instead, be creative and explore various ways to improve your pages and the user experience. The server-side features in ASP.NET AJAX only scratch the surface of the promise of true AJAX. They combine what many consider to be an optimal blend of ASP.NET page processing with the granularity of AJAX. Server-side AJAX requires a lot of processing on both the client and the server to make the magic happen, which for many applications is an acceptable compromise to gain responsiveness to the user and productivity during development. But another completely different form of AJAX is available, one that is truer to the vision of AJAX and is built into the Microsoft ASP.NET AJAX tools, and that's client-side AJAX. This form allows JavaScript code on the client browser to communicate directly with resources on the web, outside of the full page model. AJAX is an alternative communications channel between the web browser and server. It utilizes the HTTP protocol, but uses it outside the traditional full-page post and get actions on which the wild, wild web was built. As originally conceived, AJAX acts as a precision tool to surgically inject updated data only in the sections of a page that need it. In contrast, a full-page postback is a meat axe that tears down the entire page and rebuilds it from scratch. The future of the web is going to be built on AJAX and similar tools on the client. Microsoft's AJAX client library is a rich framework that extends client-side JavaScript, making it much easier to write code that enhances the responsiveness of a web page in the browser. It adds classes and resources that you can use in any web application, not just applications in which you use AJAX. Microsoft designed the library to be consistent with aspects of the .NET framework, particularly in its object orientation. You can even use the library in other development environments since it's not tied directly to ASP.NET. The library has browser compatibility features built into it, so it's likely that your code will run fine in most common browsers. What we're going to do now is explore a few of the techniques of the client library and see how to use it to make two kinds of web service calls. Making the calls directly from a page on the client. One is calling a web service from the browser, and the other is calling a server-side page method. The first thing we're going to do is look at calling a web service from a browser. Here's a client web service web form page. I'll go ahead and run it so you can see what it does. Here's the initial page, and as you can see, it has a label, some additional static text up here, a text box where you can enter a product ID, and then a button that when you click it will check to see how many items of that product are in stock. Obviously a very simple user interface, but what's happening here is it's using client-side code in order to make a call to a web service to get that current inventory. If I change the product ID, click it again, notice that it's using AJAX. It's not causing a full page postback. And in fact, it's not even causing a partial page postback. So this is client-side AJAX. So let's see how this page is implemented. Here's the inventory web service that it's using. This is defined in inventory.asmx. This is a fairly standard ASP.NET web service with methods to get inventory information from Northwind. But to use this web service with the AJAX client library, the service class requires one other attribute in addition to the usual web service attributes, which is script service. And you can see that attribute right there. That's what causes the script manager to create a proxy object that makes it easy to call into this web service. This particular application uses the getInventory method, which is right here. It's decorated with a web method attribute, which enables this to be used as a web service, and it passes in a product ID, a single integer. The rest of the code is fairly straightforward ADO.NET. It has a return value of a short. It uses a connection string that it gets from web.config. So there's a helper method here that takes care of reading that from the config file. And then it's going to select units in stock from products where the product ID is equal to the value that we pass in. It news up a connection, creates a SQL command object, adds the parameter of that product ID that we pass in to the method, and then calls the execute scalar on the SQL command object in order to get the number of items in stock. Now, if there's any problems with the call, it's going to be caught in this catch block. And then the code checks to see if the message is object reference not set to an instance of an object. The reason we're looking for that specific message is that that means that the product ID is not valid. And we raise a new exception with a little bit more meaningful error message. Otherwise, if anything else went wrong, we just rethrow that same exception. Otherwise, if everything goes okay, we close the connection and then return that inventory value. All right, that's all that's necessary to implement the web service that the client-side code uses. So now let's go back to this sample page. Now we need to do a little bit more work to implement this. There's several pieces in order to make the web service call and make use of the response when it's retrieved from the server. Because we're not using a partial page postback, we have to do more of the work to update the page using the data that's returned from the server. So let's first look at the HTML code. So we have some static text, a link back to the default page within the application, and here's a script manager. This is necessary in order to provide the various scripts that the client is going to need in order to call this web service. Notice that I'm not defining any specific scripts here. So the script manager is going to determine the scripts that are necessary by the client. But I am using the service reference in order to provide the reference to that inventory service. So this is going to cause the script manager to create a proxy object that wraps around that web service to make it easy to access within the client code. And then we have the other parts of the visible page. We have this input control with initially a value set to 1. So this is a text box that is going to allow the user to enter a value, a numeric value for that product ID. And then here's the Get Inventory button. That is going to retrieve the current inventory. And then finally, here's the div tag where the response will be inserted into the page. There's one other attribute here on the script manager that I want to talk about. It's Enable Partial Rendering, and it's set equal to false. This is going to reduce the amount of JavaScript that the page has to download at runtime. Because if we're not using an update panel, there's no reason to download the scripts that support the update panel down to the client browser. So keep that in mind. If you're using only client-side AJAX, you'll want to set that attribute to false. All right, the last piece here is the client-side JavaScript. So the first item here is a function that is implemented by the AJAX client library. This function is guaranteed to run after all of the HTML elements of the page are available. So you can write different script code here that accesses the elements. And in this case, we're going to get a reference to that button and then add the Get Inventory function to run when the user clicks on the button. And to do that, we're using the AJAX client library's add handler method. So once the page is loaded, this handler is defined so that the button is wired up. Now we also could have used the onClick event procedure, but this is showing an alternative way to do essentially the same thing. So here's the Get Inventory function. Again, this is the function that's going to execute when the user clicks on the button. The namespace for the application is Rich Apps, and it's going to use the inventory web service and specifically call the Get Inventory method. In order to make the call, it's going to get the value that the user entered in the text product ID text box, and then provide two methods: Get Inventory Success if we successfully returned a value, and Get Inventory Fail if there was a problem. Similar kind of pattern that we use in various places throughout this course. So here's Get Inventory Success. JavaScript will automatically pass in the result that was returned from the server. And then we're going to go ahead and create a string that displays the number of inventory items in stock. Otherwise, if there's any kind of problem, we get an error object passed to Get Inventory Fail, and we're just going to display the message. And in this case, if we request a product ID that, say, doesn't exist, we're going to get the error message that was defined within the web service over here, so that we get a meaningful error message. But otherwise, if anything else goes wrong, we'll just get the underlying error message. Not really the most robust client-friendly or user-friendly error message system, but it works for the application. So let me run the page one more time. You can see that it's working. I'll add another value here. And then I'll request a product ID that doesn't exist in the Northwind database. All right, and this threw an error. Notice that instead of passing the error through to the user interface, it was caught within Visual Studio. This is because I started the application with debugging, and then I entered a non-existent product ID. So Visual Studio traps that error rather than passing it on. If you want to see the behavior as users experience it, then you want to, instead of running it with debugging, so I'll go ahead and stop this, close this down, stop that. I just want to right-click on it and view it in browser. In this particular case, and actually I need to go to my page, right-click and view in browser. And now the debugger isn't going to be attached to the process, so I can see what the user is going to see when they enter an invalid product ID. One of the interesting things that you can do with client-side JavaScript using the AJAX client library is to call a page method from client code. This means that if you have an existing page with a server-side method, you can call the method directly from client-side JavaScript. And you can do it without either a full or partial page postback. Well, okay, this may seem just a little bit counterintuitive. Doesn't server-side code in a web page in ASP.NET by definition require a postback? Well, as it turns out, not at all. ASP.NET allows this by turning the method into a proxy web service that is callable from client-side script, very much like calling a regular ASP.NET web service. So let's take a look at how this works. Here's the client page method sample. This implements the same kind of inventory checking application as you saw in the last sample. So I'll go ahead and run the page just to show you what it does. Same user interface. We check the inventory. We can use different values. And we can put in bogus values and get a message that it's an invalid product ID. So the overall application is the exact same, but it's structured quite a bit differently. So the first thing we need, of course, is a method within the code behind file. So I'll go ahead and view the code here. And here's the getInventory method. This was pretty easy to write because I pretty much just copied it from the inventory web service file. So I pass in the product ID, and it runs through the same code. I still need the web method attribute on the method because this identifies this as a method that can be used as part of a web service. But notice that I don't need the script service attribute on the class itself. In fact, I have no attributes whatsoever. Because this method is contained within the code behind file, that's no longer necessary. All right, let's go back over to the web form. Because the script manager is a little bit different. You no longer need the services element in order to identify the external web service that you want to call from this page. An external web service is outside of the current page. We're staying now within the confines of the client page method page, so we don't need that. The other change that's necessary is to enable page methods. And you can do that with the enable page methods attribute and set it to true. This is going to cause an additional object to be created and sent down to the browser. And we'll take a look at that in just a moment. Otherwise, the rest of the page is pretty similar. So we have the product ID literal text. We have a text box where the user can enter an ID. We have a button that the user can click to get the inventory count, as well as a div tag that will be updated with the inventory count. Same as the previous sample. We still need client-side JavaScript code. And here's that page load method again. And we're again using the add handler method in order to associate the getInventory function with the click event. The only change that you need to make within the client-side JavaScript is in the calling of the getInventory method. Whereas before we were referencing the inventory proxy object, here we're going to use the page methods object. This is the object that was created because we set enable page methods to true. Otherwise, it's going to execute the getInventory method, pass in the value of that text box, and then call either getInventorySuccess or getInventoryFail based on whether or not there are any exceptions raised.